All right, so in this video, we're going to look at solving a logarithmic equation. And we have that equation right over there on the right-hand side. And instantly when I look at it, I know that I want to isolate x, right? That's what we're trying to do when we're solving. We're really trying to find the value of x, which means we need to isolate it. And what annoys me is that it is in two separate locations. It's inside of two separate logs. I kind of wish that was just in one spot. The other thing that I notice or that I think about is that I know, like when I look at it, that variable is inside of the log, and I want to get rid of the log, and an easy way to do that is to convert the logarithm into an exponential form. But again, I can only do that with a single log equation. With a single log in it, I can create that into exponential form. So I really would like this to be a singular log. And so what that means for me is that what I really like to do is I'd like to combine those two logs there on the left-hand side into one. And luckily, we know our logarithm rules, our logarithm properties. Since we're subtracting two logarithms, we're subtracting two exponents, if you will. That means what we're going to really do is we're going to take the two powers, and the two powers were being divided, right? So those powers are the things that are inside in this case, or the exponential expressions. So since I was subtracting those logs, I'm dividing the inputs inside of the logs themselves. And so I can rewrite it this way. Now, that ultimately solved really all of the things that I had wanted, right? Like I wanted x in one spot, inside of one log. I wanted to be able to convert it to an exponential, which means I needed one log. And so now I can really go ahead and do what I had wanted to do in terms of convert it into an exponential equation. So I know that the base is 4, the exponent's 1/2, and that's going to make the x over x minus 1. And I ultimately know that 4 to the 1/2 power is really just the square root of 4, which is 2. And so I can say 2 is equal to x over x subtract 1. And then this looks a little ugly for me. I don't really like that denominator. I wish it wasn't there. And so I'm going to go ahead and I'm just going to solve this using some good algebra. I can get rid of my denominator by multiplying both sides by x minus 1. Because it would clean it up for me. It would make it look better. And so that would really give me 2x subtract 2 equals, and that would cancel on that side. So I'd be left with x. And now it looks pre-algebra-ish in nature. And so I'm going to go ahead and solve this. I can add 2 to both sides, and then I could also subtract x from both sides, which I'm just going to go ahead and show all in one swoop because we can handle this if we're at this point, And then I'm going to write it up here so we have more space. I'm going to be left with x equals 2. So that seems to be my answer. Now, inside of any solving log equation, we always want to make sure that we double check. If I put this in, would it cause any issues for me? And ultimately, it doesn't look like it would, right? Because I'm not allowed to put negatives inside of logs. Logs can't have inputs that are negative. And so I would be fine there. And so I solved this log equation. I'm going to go ahead and double check it by hand just because I can. So when I do this, I would have log base 4 of 2, subtract log base 4 of 2 minus 1, and that should be equal to 1/2, which I know over here, what's the power, or what's the exponent on 4 that made 2? Well, that's 1/2, because 4 to the 1/2 is 2. And then this would be, what's the exponent on 4 that made 1? Well, that's 0. And this is indeed true, so my work checks. So again, what I found is that x equals 2.